Hi, everybody. We're going to be talking about thunderstorms today. First thing, just let you know that we're going to be doing some diagrams. These are going to go along with the two modules about the role of the skywarn spotter. And I'm going to let you do that one on your own. There's a couple things in there that I want you to know, but right now, go figure out what does ACEs mean. So I'm looking for ACEs. You better know those words, okay? Because that is really the way that we want to be ready. The spotter network that we had here has been for a long time, going on since the 50s and 60s. Now there's people who storm chase like I do. There's a lot of mobile spotters. There's everybody at local areas, but they do get trained in some basics of thunderstorms. It's really not that much. We're not going to do a lot of it today, but we're going to do some of the basics of thunderstorms. So keep that in mind and just go through that spotter, the role of the skywarn spotter. Be careful when you take the quiz and you'll be good. And the other one is thunderstorm basics, convective basics. So that's what I'm going to be referencing. I'm not going to go into that, but I do want you to take a look at that, do that module. You'll be taking the quiz. One of the things on that I do want to point out is that there's a lot of photo galleries. So take a look at some of those photos and see if what we talk about makes a difference, okay, and understanding some of those photos. You can go kind of quickly through them. You don't have to go really slowly, but do a good job, and that's what you're going to be working on, okay? So we're going to start with a screen share, and we're going to be talking about thunderstorms. So the thing that I want to kind of start with in terms of thunderstorms is when we talk about warnings. So I'm going to go over here. This is current right now, and these are severe thunderstorm warnings for different areas. Remember that severe thunderstorm warnings are going to be from the local weather service office. This one, in the case of this severe thunderstorm warning, is in Colorado for Pueblo. It says where, what's going on, what time is this going to be in effect, the hazard, 60-mile-per-hour wind gusts, quarter-size hail. So that's 60 miles an hour is severe. It also deals with large hail, 1 inch in diameter. That is severe, if you recall. And there's just some information. But when we go into severe thunderstorms, we are going to be doing something from the SPC, which is the Storm Prediction Center. And I'm going to show you this just for the sake of tomorrow. And so I do want you to kind of know this setup here, is that we've got risks of severe thunderstorms. So the Storm Prediction Center issues what's known as a convective outlook. Convection to a meteorologist is vertical motion. It's the heat transfer. So we have thunderstorms that are building up and down, and they're going to talk about when they're severe. So this is an outlook for the day 2, and it says that there'll be general thunderstorms in all this light green. And then over here, we have the first risk, and that's called marginal. So I do want you to know the risks for severe thunderstorms, marginal risk. The second in yellow is called a slight risk, okay? Beyond slight, this third level is enhanced. Kind of a weird one. I'm not a big fan of the term enhanced, but that's what it is. Then the red here would be moderate risk. That's the fourth. And then the fifth category is a high risk. So write that all down because this is the Storm Prediction Center, the SPC, and when they're forecasting for severe thunderstorms, what are the risks? Marginal, slight, enhanced, moderate, and high. And as a person who would be living your life, this is something you probably ought to know. What does that mean to be a slight risk? It basically deals with probabilities of severe weather within a point or near a point. So slight, marginal means it's not going to be that bad. Slight means that you'll get severe. It may not be widespread, but you could still get some pretty significant events. But when we start getting enhanced and moderate, you're looking at more of a significant severe weather threat. So anytime you may hear that we're under an enhanced risk for severe weather, you need to be aware. You need to be thinking about what would you do later on in that day. Remember, what you're looking at here are all outlooks. And we have the day 1 outlook, we have the day 2 outlook, that's tomorrow, we have the day 3 outlook, and then days 4 through 8, sort of a long-term forecast. Now they also issue discussions called mesoscale discussions because a thunderstorm is a mesoscale event. And they'll talk about what's about to happen, and then they'll give you the watches. So if I look here right now, I'm looking at a couple of severe thunderstorm watches. Now we call these blue boxes, so I'm going to show you something else about this. But these are the areas that they're outlining for the potential of severe thunderstorms later in the day. The solid colors here are severe thunderstorm warnings, and those are issued by the local office. So if I go over here, maybe to a satellite picture, and I know that we've talked about satellite on the modules. So this is just looking at the clouds where that is. I can kind of put in here, I think this is a cool little product here, where I can show you some more enhanced big thunderstorms. So Oklahoma's got a lot of thunderstorms, but they're not very strong. Here's where I'm concerned about it, and I can put in here, and oops, I'm sorry, and say, okay, where are the watches and warnings over here? And there they are. So I put them where these situations are. Now keep in mind that I also have that text page that we've gone through before, which we talked about. You can put that in your browser if you want to take a look at this, and hazards. And here's the more traditional colors where we're going to color code this as soon as it comes in here. Ooh. Take a little bit of time. Oh, yeah, here it is. Well, there's a couple of severe thunderstorm warnings. I fear that the National Weather Service, who transmits the data, is not up and running. And that's probably why stuff is a little bit delayed, because there should be severe thunderstorm warnings here, but nonetheless. And then there's your convective outlooks where we can see that before. Keep in mind that the Storm Prediction Center is in Norman, Oklahoma. They're putting out the watches. Local offices do the warnings. Okay, so what are we talking about? We're talking about thunderstorms. So what is a thunderstorm? First of all, I'm going to start with a blank screen here. Talk a little bit about what a thunderstorm is. And, oh, let's use a different color. How about that? Let's use black. Let's go to the cloud. Oh, that's not black. That's still pink. That's the color I want. Okay. So there's a thunderstorm cloud. Okay, and that's what we're going to start with. And just to keep you, in the loop, remember we are looking at a cross section. And if it's a cross section, then I'm going to draw the ground over here, little hatch marks. We've done that before. I'm not going to draw any isobars in here. We're just kind of looking at what this is doing. Now, a thunderstorm is basically a result of air that has come together. If you remember mass continuity, it's converging. If it's converging down below, the air is going to rise. As the air rises, it's going to, pressure is going to drop, the air is going to expand, and the temperature is going to cool, dry adiabatically, up until we get to, what is this level? What is the base of the cloud called? If you recall, see if you know the answer, LCL. Okay, so here we have the base of the cloud, stands for LCL. What does LCL stand for? Lifting condensation level. So what I need you to do is, I need you to imagine that I've taken a box, just a parcel of air, and I've lifted the box expanded. In that process, the mixing ratio stayed the same, but the temperature went down, which means the relative humidity is going up. And so at the LCL, the relative humidity is now telling me that the RH is 100%. And once the air is saturated, the relative humidity is saturated all throughout the cloud. So the cloud actually becomes what we are talking about when we say a parcel. So I lift the air, it goes up, and then I get saturation. Inside the box is a cloud. Now, if you recall, there's water vapor condensing, and that releases latent heat. So I'm heating the air inside the box, but it's still trying to cool. So what it does, and I'm going to show you what I mean by that, is that the air will cool from there to there. How is it cooling? The air cools dry adiabatically, which is how much? Which is 10 degrees C per kilometer. Okay. Once I get to the LCL, now it's going to cool. How? Now I'm going to use a different color just to show you that. Once I get here, the air now cools as you continue up in the cloud, but it cools. Air in the cloud cools wet adiabatically, which is less than 10 degrees Celsius per kilometer. So that's all we're going to know about it. It's just slowing the rate of cooling outside or inside the cloud. So I want you to imagine that there is a box of air in the cloud, It's this box that has gone up and expanded. Now, what I want to do is I want to compare the temperatures from inside the box. Oops, let's get the arrow. I want to compare the temperature here inside the box with the temperature here outside the box. And if this air is warmer in the box, so I'm going to write this down because this is so important. If air is warmer in the cloud, which is really the parcel, then outside the cloud, the air is said to be, what's the word I'm looking for? Buoyant. Okay? Buoyant, which means it's less dense than the air outside of the cloud, which also means the air that the air is unstable. Okay? That parcel will now rise by itself. Okay? So what we're saying is that this parcel, if it's warmer than the air around it, it will rise by itself. And we say that's buoyant, and that means the air is unstable, which means in a cloud like this, the air is rising by itself. And that's the basis of what a thunderstorm is. I need three things to get a thunderstorm. Three ingredients for a thunderstorm. Thunderstorm. Okay? First ingredient is lift. Notice I had to lift the parcel and let it go. The second ingredient is moisture. Now, we already said there's moisture in the air. The mixing ratio is the best measurement of water vapor content. I could also think about the dew point. But the third ingredient now is instability, which is the ability of the air to rise on its own. Now, I want you to think about this. Lift. I lift the box. Why does the box go up to begin with? I'm forcing it up. So forcing may be sources of lift. Forcing may be mountains, sea breezes, fronts, dry lines, anything that's causing the air to have to go up. That's lift. But eventually I get to the cloud base, the LCL, and if the air continues to rise and I let go of the box and it's buoyant like a hot air balloon, it rises by itself on its own. And then we say that is unstable. So to get a thunderstorm, I need to have lift, I need something to force the air up, convergence down low, I need moisture, and I need the air to be unstable, which means that parcel, the air in the cloud, is warmer than the air outside the cloud. Now, the measure of instability is called CAPE, which stands for convective available potential energy. That's just one of those terms that you need to know what CAPE is. The more CAPE, the more unstable. Here's an important point. The more unstable the air is, the faster the air in a thunderstorm rises. You should write that down. That rising air is known as the updraft. So when the air rises in a thunderstorm, that is what we call the updraft. The tower of clouds themselves is the updraft. What do we call that? We call this a cumulus cloud. It's puffy, like cauliflower, so cotton balls, but it's got vertical growth. That's cumulus. If it rains, it is a CB, which stands for cumulonimbus. Okay? Now, it is my hope that you have heard of this term before, cumulonimbus. That is the definition of what a thunderstorm or a thundercloud is. It's a cumulonimbus. But keep in mind That it says if it rains. Well, here's a stupid question. Go ahead, give me your dumbest answer. Which way does the rain fall? And you're all going to want to be smart and say it falls down. So we start to get rain falling over here. Okay? And as that rain falls down, okay, this is forming, and I'm going to use this color here. This forms what we call, what do you think that's called? Indeed, that is the downdraft. So a thunderstorm actually is an updraft and then a downdraft. And the downdraft is where the air falls down. And part of it is that the precipitation will pull the air down with it. But there's something else going to go on with that, which we'll get to in a second. So if I said, what is a thunderstorm? A thunderstorm, in my mind, and it should be in your mind too, is more than a thing, it's a process. It's a process where unstable air, which is warm, rises, and then air sinks in the downdraft. So we have the updraft of the air going up and the downdraft coming down. But here's the thing about the downdraft, it's usually cool. We're going to get into why the air is cool in a second here. But that's what a thunderstorm is. So you go outside and you see a cloud and it's going up and starts to rain. You know that that cloud is indicating what the updraft is. And then the downdraft is the rain that's falling. Once it starts raining, we call it a cumulonimbus. Now, a lot of times, there's going to be lightning in here, right? So if I had lightning, where lightning is going to be forked like this, okay? Boom, and that's what lightning is. Now, I'm telling you, I fail students if they spell lightning wrong. So if you spell it wrong, you're getting an F, not just on this assignment, but for everything in this course. And I'm going to go on your transcript and change all of your grades in the past, all the way back to kindergarten, to an F. This is how you spell lightning. L-I-G-H-T-N-I-N-G. Okay? That's what lightning is spelled like. There's no E in it. I've had to unfriend people because they spelled it incorrectly. Lightning is this really dangerous thing. So I'm going to pause here for a second. I'm going to come out of this. I'm going to close this up. And I'm just going to pause for a quick second on my Zoom meeting. And I'll stop sharing for a second because I want to get a... Okay, here's just a quick lightning video. So let me share the screen and we'll go.
They say lightning never strikes the same place twice, but what happens if it strikes once? Hey guys, Dan at the National Weather Service. There are a lot of myths out there about lightning. And did you know it can strike in ways you never thought possible? You could get struck walking your dog, or even just standing on your porch. The fact is, lightning is more dangerous than you think. And just to let you know, lightning can strike the same place twice. Lightning strikes the United States about 25 million times a year. And of the hundreds that are severely injured, about 40 million people die.
That's a lot of people.
Interestingly enough, lightning and tornadoes are similarly as dangerous and as deadly. A common misconception is that all lightning strikes are fatal. Good news is, that's not true. Researchers in the lightning safety community say that 90% of people struck by lightning survive. Of those that do survive, some are left with lifelong neurological problems. Also, a study published in the Journal of Neurologic Clinics states that the primary cause of lightning death is cardiac arrest. Basically, your heart and your breathing stops and you lose consciousness. Now let's move on to something even more striking. Lightning is a sudden discharge of electricity from the cloud, the ground, and the air. It can even occur in other instances like volcanic eruptions, but for our sake, we'll just stick with thunderstorms. True or false? Lightning only occurs underneath a thunderstorm. False. Ever heard of a bolt from the blue? Lightning can actually travel 10 miles or more horizontally from a storm.
Okay, that's probably something you haven't heard of. It's called a bolt from the blue. But the idea is there is something in NCAA, National Collegiate Athletic Association, that if you have, it's called the 30-30 rule. So I'd like you to write that down if you would, please. 30-30 rule means you have, if you see lightning and then hear thunder within 30 seconds, then you should stop play. and they're going to cancel play. So that's 30 seconds between the lightning and thunder. Now, lightning and thunder is 5 seconds per mile. It's called the flash boom ratio. Okay, so flash boom. And the thing about flash boom is that if you see lightning, you count to 5. That lightning is 1 mile away. It's not 1 second per mile. It's 5 seconds per mile. So we're going to show you some fun videos about that. So basically they're saying if you're within 6 miles of lightning strike, you need to cancel the event. And then you have to wait 30 minutes after you hear the last thunder. And that would be what we call the 30-30 rule. So that's governing NCAA. I think you need to write all that stuff down. Okay, so flash to boom, 5 seconds per mile, 30-30 rule. This is how people stay safe. So she's going to continue on, and we'll just keep watching, okay?
In 2001, 2 guys were playing football on a beach in New Jersey under sunny skies when a lightning bolt from a thunderstorm offshore struck and killed one of them. Okay. You're probably thinking right now, I get it, lightning's dangerous, but how can I protect myself and my family from it? All right, let's go over a few steps. If you're expected to be outdoors, plan ahead. Check the latest forecast at weather.gov and click on the location that you're interested in going to. If there's a better weather day, that's a better option. When out and about, have a game plan on what action you'll take if lightning threatens. Have a shelter in mind of where you will want to go to. It needs to be a building with at least 4 walls, a roof, wiring, like a home, a school, a church, or an office building. But stay away from pipes, metal objects, showers, sinks, bathtubs, and electrical equipment such as.
Okay, so I think you need to know that, right? You want to stay away from anything that's metal where electricity may be conducted to you. You'll get an indirect stroke. When lightning hits you, typically what will happen if you're going to die is it'll stop your heart. So you got to be careful of that. So stay away from anything that's going to give you a possible charge. Inner ear burns come when you have corded telephones. Most people have cell phones now, so that's probably not a big threat much anymore.
Stoves, radios, corded telephones, and computers. Another shelter would be any fully enclosed metal top vehicle. So don't even think about that golf cart. You wouldn't stand a chance. Let's say you're in the middle of nowhere and you don't have any shelter. What do you do then? Well, my fellow Weather Service colleague and lightning specialist, John Kinsenius, suggests if you're in a group, spread out. Avoid open areas. Try not to be the tallest object in the area, and do not be near tall or isolated trees. However, keep in mind there are no safe places outside in a thunderstorm. Watch for clues of an approaching or developing thunderstorm. If you hear thunder, the storm is already close enough that lightning can strike you, and you need to get to shelter immediately. Once in a safe shelter, stay there for 30 minutes after the last rumble of thunder. Puffy white clouds that don't change much shouldn't cause any worries. If these clouds start to grow up or distort space.
Okay, see, that's cumulus. This is a very thin thing, but in this picture is, but this is your updraft. This is about to become a thunderstorm.
You should be prepared to take shelter from lightning. This is a thunderstorm cloud, and you should seek shelter immediately.
So a couple things within this thunderstorm is the very cumulus. Notice how puffy, like cotton they are. And this is where your updraft is, and the updraft goes all the way here. Now we're going to see soon that the top of the storm gets icy. This is a cirrus cloud, C-I-R-R-U-S, and that's the anvil of a thunderstorm. This is also in your module.
Now here are some common outdoor activities that people participate in, and you tell me if you would be safe from lightning. A day at the golf course. Watching a thunderstorm from your porch. Boating. Mowing your lawn. Whoa, that was enlightening. Now here are some real-life examples of what people were doing when they got struck by lightning in recent years. Some of these common activities might surprise you. Sheltering under trees, fishing, on a boat, riding a motorcycle, mountain climbing, hiking, football practice, hauling hay in a tractor, kids on bikes, standing in the doorway, taking out the garbage, mowing the lawn, inside talking on a landline phone, walking dog, standing next to a window, playing organ in a church, and doing something as simple as getting a book from their vehicle. As we like to say at the National Weather Service, when thunder roars, go indoors.
Okay, that's a motto, guys. Let's go to this motto. When thunder roars, go indoors. I'm going to ask you about two mottos. This is the first one. When thunder roars, go indoors. That's just a nice safety rule that you ought to remember, okay?
Go indoors. For more information, go to lightningsafety.noaa.gov. Yeah, I gotta go.
Okay, so little thing from the Weather Service. Now I'm going to do something here, and I'm going to go to, oh, there's the severe thunderstorm watches that came up. They finally got populated. And there's all these dark ones, there's severe thunderstorm warnings. So it's a pretty active day down in Texas Panhandle and up here in southeast Colorado. But what I want to do is I want to go to our Blackboard page, and we're going to look at one of our classes. And this is from the summer, so if you're not in the summer, this is not you even. But I think I put on here on this worksheets, not really a worksheet, but I said great videos of various weather phenomena. And I've got a document in here that talks about this stuff. So I want to show you a couple of these, and you can kind of play with the rest. But I want to show you this one. I think you'll like this one. So yes, I want to watch that link. And I want to watch this advertisement first. Okay. That's pretty good. Watch this again. So, really cool video. What happens is the lightning hits the tree, it's super hot, creates all sorts of burns if it were to hit you. If it doesn't stop your heart, you'll get burns, and that's a bad thing. I've seen people who have their toenails actually blown out and their shoes melted into pavement. But what happens is it gets so hot, and when you heat a gas, it expands that gas, and so all the liquid in there goes to vapor. It expands, knocked off the bark of the tree as it blew off, and then it broke a branch up high, and then that collapsed down on it. So you don't want to mess with this. There's one over here. I'm not sure if I put it in here. Soccer game lightning. I just thought you might enjoy this one. This is pretty intense too, so let's go here. Oops. No thanks. So here we go. So just some guys playing soccer. Now, you remember the flash to bang rule? How long did it take between the flash that you see on the screen and the thunder? Let's see if I can even get there. So lightning, it hits part of the field. A couple of these people got badly from the shock wave, and sound knocked them kind of out. So they were lucky that nobody specifically died in that scenario, okay? So pretty incredible stuff. Now I want to go back to this video, and I want to kind of encourage you to take a look at a couple of things. One of the questions on one of the worksheets was cocoa rise. You need to know that. We're going to do a couple more of these coming up. But I thought I would show you something else about wind, okay? So what happens when I've got a microburst? And we'll go here for a second. Now this is just some guy in Oklahoma watching a thunderstorm come down here. Now, for a second I'm going to stop and I'm going to go back here. And I'll put the white screen up there. Why is this downdraft cold? Well, here's the thing. Do you see that the rain is falling outside of the cloud? then the question becomes, well, what happens when rain is not in a cloud? Well, the answer is it evaporates. And if you get heat released when water vapor condenses, when water evaporates, there's cooling. Remember I had you lick your hand and blow on it? So the raindrops fall, and that cold air is affected by evaporation. So what I'm saying is that if I think about a parcel coming down, that parcel comes down, it gets colder, and it becomes unstable downward. So unstable air is upward. Unstable air can also accelerate downward. And so that air comes down very fast as it evaporates. If that's the case, what's it going to do when it hits the ground? It doesn't dig a hole. It diverges. It spreads out. Okay, so I go back to this picture here, and I'm going to watch this video. And I'm going to skip ahead. So there's outflow wind as rain's coming through, but watch what happens and listen. Starting to get hail too, little bits of hail falling. So it's still kind of funny. It's definitely getting more intense now, right? Those are probably... So very rapidly, you go from, oh, it's kind of windy and he's laughing, to, whoa, intense winds. Remember, that 60-mile-per-hour winds is severe. This is probably more like 80. So that's pretty good. It knocked down some of the fences. The little small trees were being bent quite a bit. So lots of things going on when you've got the downdraft, okay? Now, the downdraft is the strong winds, the outflow, and when that happens, you can do other things as well. Okay, so I'm going to look at a haboob, which is a dust storm. So now you've got areas in Arizona. This is kind of a silly musical diagram. But this is driving through a dust storm. So this is what the outflow, the cold air of a thunderstorm would look like if you could see cold air, but you can't. But you can get it filled with dust. And so it's what they call a haboob. This is a Middle Eastern word for this large dust storm that they have in the south. And think about Southwest. It's very dry, but if thunderstorm goes, raindrops are going to evaporate and then blow out a lot of wind. So here he's driving through it. This is late afternoon. Now watch how dark it's going to get. And just within a few seconds, it's almost like night in the middle of this dust storm. I always tell my students, one of my favorite movies is The Mummy, and they had a scene filmed in a haboob. And I always thought when I first saw it, what a great presentation that was, what a great special effect. Well, the reason it was so realistic is because they actually filmed it in a haboob, in a sandstorm. So that's exactly what happens in the Middle East, and this is what's happening in the desert Southwest. So I think that's pretty amazing. Now this next one, I'm going to show you something, and it's a little bit more disturbing, so I hope you can brace for this. But when we talk about a severe thunderstorm, these are the things that can often happen. This is in Indiana. State Fair, severe thunderstorm, not even that strong of winds. So here's a large venue where people were not prepared for a severe thunderstorm. Now, there was a severe thunderstorm warning. There was indications that there would be some severe weather coming through, but this large venue location did not do anything to prepare for people. So here it is again. Large stage. They were waiting for a band. They should have evacuated these people, sent them back to at least their cars, and all these people in front are just hanging there. If you ever been to Northerly Isle in Chicago, you get the same type of scenario. Large stage, winds that were somewhat strong, 50, 60 miles an hour, still did this. Just, it's incredible. And several people were killed by that. So when you hear of severe thunderstorm warnings, you have to understand they're not always going to be horrible, but there are areas that you could be in risk. So you got to be aware of that. Okay, now I'm going to go back to my diagram just for a second. And I'm going to say this is the updraft. Okay, now we mentioned something else. We said up top, as the temperatures get colder, you eventually get what we call the anvil of the thunderstorm. And this anvil is made out of ice. It's very cold. We're going to be getting into all that stuff in precipitation type forecasting. So we have a cirrus cloud, which is made of ice and is the anvil of the thunderstorm. So that's up top. And we have all this air ascending in this region. We have this overshooting top, and we have the anvil. It's what we call glaciated, Glaciated. Again, we are going to get into this with precipitation type. But because I've got a thunderstorm going up through an ice layer, I do start all thunderstorms as snowstorms up high in the clouds. That separation of charge because of ice is what causes lightning, but it also develops hailstones. And a lot of times the raindrops in there freeze and they come back down. They take several circuits before they fall as large hail. So we're going to be talking about precipitation types. I think we already had a question on the previous worksheet of freezing rain, sleet, or hail. Hail is this one. It's large chunks of ice. If it's an inch in diameter, I was going to say in that wind storm in Oklahoma, that was probably about an inch in diameter hail. Then we call it severe, but hail can get really big. So what I want to do is go back to our go back to our sheet, and I'm going to show you some. Oh, I don't know if I have any hailstorms on this thing. Yes, I do. And this is a great tutorial, so I'm going to show you this, and I definitely want you to watch this, and I'm going to sneak out of here for a little bit, but I want you to watch this and take notes on it. It's one of my favorite videos on explaining how hail works. As soon as we get through the ads, this is a friend of mine named Pecos Hank. It's a great story.
Hailstones crash through windows, shred trees and crops, pummel livestock, damage roofs, wreak havoc on cars and everything underneath its ground. Hail can turn a scorching summer ground into a winter wonderland in minutes. Sometimes baseballs just fall from the sky. Other times, strong winds hurl hailstones sideways like bullets. If you're caught away from shelter during a severe hailstorm, you've got a problem. Your storm cases, hail is the nemesis. Yet you proudly wear your helmets like victory's battle scars. A hailstone forms as a tiny water drop that journeys up above the freezing level in some of the most beautiful and dramatic thunderstorms. How does it get so big? And how big can it get? In an environment conducive of a severe hailstorm, this rising air or updraft is often exploding into lower freezing levels. This is the factory where hail is made. When the drop freezes, this process releases heat, which keeps the stone.
See, these are all things we've talked about.
As the little stone journeys through the cloud, it catches more and more water on the surface. The inner layer freezes, and the hailstone grows away. You can see the different onion-like layers in many of the stones. Hailstones can also grow by colliding and conglomerating with others. One of the reasons they come in such a myriad of funky shapes. Here's a disc-shaped stone with crystal star-like protrusions. Here's one shaped like a bomb. Here's one shaped like Stu Griffin. These upward winds sustain ice pebbles, and the longer they hang around up there, the larger they tend to get. But some intense updrafts blow up over 100 miles per hour. This is where things really start to get green. Eventually, the weight of the hailstone overcomes the updraft winds and it falls to earth, often appearing as bright white curtains. Isolated thunderstorms with hail downdrafts set the stage for the most vibrant rainbows. That goes down to the brightest rainbow I've ever seen. That is great. If the storm matures into a high precipitation monster, the thick hailfall often has a breathtaking turquoise below. And because these storms often occur in the late afternoon through evening when angled yellow sunlight blasts into the hailport, the yellow and blue make green. Which is beautiful green. We got turquoise green color. And that's why people associate green storm clouds with tornadoes. When photographing hail, you need a size reference people can relate to, like a coin, a hand, or Barbie's head. The largest hailstone officially measured landed in Vivian, South Dakota, July 23rd, 2010. It was 8 inches across and weighed almost 2 pounds. I want to know what an 8-inch hailstone would look and feel like, so I'm making an artificial one in my freezer right now. It's almost ready to pull out and smash into something. So how do storm chasers deal with these daily bombardments of hail? Often the same powerful updrafts that create giant hail drop tornadoes. These storms are called supercells, and supercells are shy about people filming their dangly bits. So they throw hail at you and your cameras.
There is a prototype on the ground. Oh, no, the hail is huge.
In fact, these storms do everything they can to deter storm chasers from exposing their dangly bits to the world.
I'm a snowplow.
On the side of the road. They cover the road in ice so you can't drive fast. Then they cover the roads in wet slippery leaves so you can't drive fast. If that doesn't work, they drop buckets of hail to reduce the air temperature to the dew point, causing hail fog. Doesn't that sound like fun, chasing tornadoes in the fall? And of course, if that doesn't slow you down, they break your windows. Most chasers just avoid the hail force, often revealed on radar with a pink or purple spot. Other chasers would rather sacrifice portions of their precious view with metal guards to block the icy shrapnel as they punch through cords. And others have the luxury of thick, super heavy-duty glass to shoot through. Me, I yell 4-letter words at it, and then I call a buddy who just replaces my windows for $100 a pop. That just came inside of my car and broke. Let's see if that big stone in my freezer is ready to smash into something. So this is roughly the size of the largest hailstone ever reported. Can you imagine this sucker hitting you in the head at over 100 miles per hour? How hard to do the damn thing? Storm chasers need to mount these all over their cars. Hail injures about 24 people per year here in the U.S. The last hail-related death occurred in Texas in 2000 after a man got struck in the head. On April 30th, 1888, devastating hailstorms killed 246 people in India. On average, hail causes almost $1 billion of damage to crops each year in the U.S., and unlike rain and snow, there isn't a single thing useful about it. Hey guys, check out the size of these hailstones. Hey guys, check out this one Coca-Cola I just found underneath my seat. Okay, so there is one use for hail. Thanks for watching, friends.
Okay, that's a fun video by Pecos Hank, and that's something important. Now, I'm not going to take the time with you to go through this set of videos with tornadoes, but I'd like you to go through some of them on the tornadoes because we're going to be talking about that soon. There's a couple that I want you to do, and I just want you to give me a little write down of what you think, just a sentence about each one of the videos. I want you to see this Clem Schultz, which is up in Northern Illinois. It's the most amazing video. I want your take. What is your thought? This one, Washington, Illinois, is probably my favorite of all the tornado videos. I would also really like you to look at this video, which is Pecos Hank again, and the LA, Manitoba tornado. And then you can look at any of these other ones. There's some fun ones. There's a Russian garage. It's pretty funny. A famous one, Tornado Train, that was in Northern Illinois. So take a look through those, but especially the ones that I pointed out, and just write down a little sentence about what you see. So you're going to pause the video and do that on your own, okay? And I want you to do that because that is part of this class. But rather than me just sitting here waiting for you to look at it with me, I want you to do that on your own and just tell me what you think, okay? Now, in this idea of a storm, and we've kind of taken a look at this, so here's your updraft, and I want to point out a couple of other features to it. Sometimes there is a little feature that hangs down below this cloud, and it's kind of a lowering in the cloud base, and this is called a wall cloud. And it's from the wall cloud that tornadoes often will come. So people will often look for where the tornado is going to be forming underneath the wall cloud. So I want you to know wall cloud, and it's in the module part as well. Okay, but I'm going to skip this, and I'm going to go to a more important diagram, which is a supercell schematic. And if you wanted to do that, you're welcome to go to this link here. It's a notes material, or you could just search College DuPage supercell schematic, and you should find this. And I just want to point out a couple of things on here. First of all, you do understand that this is where the updraft is. Let's go to red. So here's the updraft of the storm. So keep in mind that the wall cloud is under here, and then the tornadoes with the wall cloud. Now you also have the anvil, okay, which is this section of the cloud, the anvil. That's the upper level winds. You get some of the heavier rains and hail that are near the updraft, but in the downdraft. There's also the back of the anvil, and underneath this anvil, there are these little pouch-like clouds called mammatus. And they both form on the back and the forward flank anvil of the thunderstorm. And you can easily do a web search for mammatus clouds. So M-A-M-M-A-T-U-S. And they're amazing. They don't even look real. So look up mammatus clouds and then look at some images of it, and it's like, wow. And those are probably going to be all real. They look really crazy. So the tornado's under the updraft. You've got the large hail. Now, cold air comes out from the rain, and sometimes a cloud forms along what we call the gust front. And that cloud here is long, elongated. That is called a shelf cloud. So if I were to show you a shelf cloud here, and just give you some pictures of this, this is pretty easy to do. You can see this, it tends to be elongated. It's pushing out from the cold air. It's cool looking. There's scary stuff. A lot of people say there's all sorts of things that, you know, freak people out, but it's awesome. And that's just outflow. So usually when you see this fly, it's not tornadic, but it is something that is more likely to be strong winds. Okay, so that's a shelf cloud. So this is your basic thunderstorm. Now I'm not going to have you memorize all these other things. That's for a different class. But I do want you to know wall cloud, and I want you to know the updraft, and I want you to know the anvil, and I want you to know mammatus. Now this one has a tornado, and the reason for that tornado is that there is rotation within this updraft. This updraft is rotating, okay? And anything that rotates in the atmosphere is because this area of rotation is actually an area of low pressure. Now, it's a low pressure in a thunderstorm. That area of low pressure in a thunderstorm is what we call a mesocyclone. Think about that. This is a mesoscale low pressure, which we call cyclone. So a storm that has rotation in the updraft has what we call a mesocyclone. The reason it's rotating is because we have rotation in the updraft. That means this storm is called a supercell. That is the name of this storm. So here's what you need to know. I'm going to say it very clearly. A supercell is a storm with a mesocyclone. A mesocyclone means that there is rotation, low pressure within the updraft. Okay? And when that happens, hail is bigger, winds can be stronger, and you have a higher likelihood of tornadoes. So anytime you're looking at supercells, you're looking at a much higher threat for severe weather. When I go storm chasing, I'm looking for a supercell. By the way, take a look at this picture here. This is a thunderstorm, and what cloud is this underneath it here? That is the updraft. That is the wall cloud of a supercell. And then over here is where it's raining, and there's probably hail in there. So this is one of the storms we chase. It's a beautiful storm. And this is why we like to go storm chasing, to see these unbelievably cool storms. Now, the reason we have a mesocyclone is the last ingredient for supercells, in addition to lift, instability, and moisture, is vertical wind shear. Oops, let me spell ingredient correctly. How about that? So the last ingredient I need, I said, what are the three that we have? Lift, moisture, and stability. Then I get thunderstorms. But if I'm going to get supercells, I need vertical wind shear. Now watch this. Vertical wind shear is when the winds change direction or speed as you go higher. So imagine the winds are down here at this direction, and up higher, they're going a different direction. That is vertical wind shear. So when I have a lot of vertical wind shear, I develop mesoscale areas of low pressure within the thunderstorm. Those are called mesocyclones. And if I have a storm with a mesocyclone, that is called a supercell. Supercells are very dangerous. They're the ones who do most of the damage. Largest hail, strongest winds, and certainly the most deadly tornadoes. Okay, so that is something to put into your mind. And I'm going to skip through there now. So there's your supercell. And the scale of tornadoes is called the enhanced Fujita scale. So this would be something that I need you to know also. You go to Wikipedia and do this, and I'm going to just kind of talk about this. We have EF0, and it gives you an estimate of the wind speeds. It goes all the way EF1, 2, 3, 4, and EF5. Okay, so it's called the enhanced Fujita scale, which says how strong of a tornado they are. Key things. They are, first of all, it's based on damage. It's how much damage does a storm do. If a storm does a lot of damage, or a tornado does a lot of damage, you can look at it, do a survey, and then say that's a EF3. If it's in the middle of the field, you don't know what it's going to be. So we don't usually say, oh, there's an EF4. We have to look at the damage after the fact and then determine it. Here's a couple things, though. EF0, EF1 are what we call weak tornadoes. And weak tornadoes are about 70% of all the tornadoes. Okay, weak. And a well-built house stands fine in a weak tornado. But about 28% of them are EF2 or EF3, which we call strong tornadoes. So weak tornadoes, strong tornadoes. And strong tornadoes are going to do some serious damage. They're usually going to pull roofs off of houses. They're going to start knocking down the walls, blowing out windows. Very dangerous to be in a place with windows. So you want to be in internal shelter. Here's a tornado safety rule you need to know. So you better write this down because I'm going to test you on it. Be in the lowest floor, most interior room. Lowest floor, most interior room. And stay away from windows. Don't be in a car. Those are bad places. Don't be in a mobile home. Those are really bad places. So you want to be in the most interior room of a well-built house, lowest floor. However, if you have an EF4 or EF5, and these are what we call violent tornadoes, spelled violent correctly, then we're talking about all the walls are coming down. So they don't happen. They're only 2%. But in the United States alone, do you know how many, let's do this. Do you know how many tornadoes there are? If we look at something like this, enhanced Vegeta scale, there's a lot of stuff on this one. EF4, EF5, now they're tossing trains, they're leveling towns, that kind of thing. They are going to only be 2% of the tornadoes, but in the United States alone, there's well over 1,000, more like 1,200 tornadoes a year. So even if you have 2%, that's still going to be a number of tornadoes that are violent. So a well-built house may protect you. It's better than nothing, but even a well-built house is going to get destroyed by these extremely strong winds. So you need to know what enhanced Vegeta is. You need to know the Vegeta scale, EF0 to EF5, and you need to know that they're weak, strong, and violent. Okay? So these are some of the things that you're going to need to know. I'm going to stop the sharing for a second. For this unit on thunderstorms. And the rest of it's kind of in there. Now, they're going to talk about gust-nados. So you should pay attention to those things in there. Those are just little whirlwinds as a result of that. And I think on that sheet of videos, there's a gust-nado that goes through a town in Japan. Kids are playing soccer. It's kind of fun. It's a funny one. If you ever have a chance, Google search hay-nado, and you'll see these little dust devils that kick up hay, and they're a lot of fun. The atmosphere likes to spin, but in the atmosphere, when you're under a thunderstorm, that spin can become extremely deadly, and that's why we have these tornado warnings, okay? We will reference a couple of other things. I'm going to be doing a review of worksheets so that you know what the correct answers are, but this is a nice solid one. Remember, do those extra videos, and I just write your opinion about what you think because you'll really enjoy watching them. They're fun videos. Okay, guys. That's it for today. Take a good set of notes on this, and we'll see you at another time. Thanks.